Assalamualaikum and hi, my name is NAWWAL binti Muhammad RADHI with the number metric DE210047. So today I will Assalamualaikum and hi, my name is NAWWAL binti Muhammad RADHI with the number metric DE210047. So today I will explain our abstract. So in this project, analyzing and designing strategies to maintain power system stability during the integration of PV system are discussed. Hence, we are able to study and addressing stability challenges associated with PV integration. And the demand for electricity is on the rise annually, but however, the reliance on fossil fuels and natural gases for power generation has led to the release of greenhouse gases. As a result, photovoltaic technology has gained popularity as a viable option for distributed generation, and this is due to its clean and abundant nature, in addition to government initiatives like the net energy metering program. And for a consistent supply of electricity to be maintained, power system stability is essential, and the fluctuating and intermittent nature of PV system, when integrated, can cause instability and affect the grid's overall dependability. The stability and dependability of the electrical system for all users is ensured by comprehending and addressing these issues. And this project shows PV system plays a significant role in the transition toward a cleaner and more sustainable energy future.
Assalamualaikum. So this is our introduction. So photovoltaic system, or we can call as PV system, become important component as well accept renewable energy sources more and more. So this PV system can provide a clean energy since they can convert sunlight directly into a power. But there are some problems with the integration of PV system into a conventional power grids, especially in regard to steady-state stability of whole power system. This is for problem statement. So for the first one, the first difficulty is from the rising demand for power. Then the dependence of fossil fuel and natural gas for the production of power leads to the greenhouse gas emissions. The third one is unique characteristic of PV systems, such as their unpredictability and uncertainty, provide a specific problem to the durability of the power system. And the last one, the group should think about government programs that encourage the use of PV, such as the net energy metering program, or we can call as NEM. So this is our objective of the project. For the first one, student can examine steady-state stability of PV power system. The second one is create a model of power system with PV integration. The third one, student can run simulations of steady-state stability on created power system model. And last but not least, the student can analyzing how PV integration affect the power system model steady-state stability.
Hi, Assalamualaikum. My name is ARDINY HAMIDAH binti Muhammad YUSOF. My metric number DE210105. So I'll continue to the next part, which is methodology. We are using power system modeling, refer to IEE 30 bus power system. Okay. In this project, we are doing analysis with steady-state stability, and then we do the increment of the load value to observe the system before it collapses. The last one is we install PV to help the system back to normal. Simulation using MATLAB. So in this part is the initial value that we refer from the Hadis Adat book. Okay, the load. This one is the load for real power, and this one is the reactive power. When we run the program, we get the voltage per unit 0.995. Next one is what happens if we increase our load value to negative 10%. So here are our table. Okay, the initial value is 10.6 for the real power, and then what if we times the negative 10%? We get 9.54, and the reactive power 1.9. We get 1.71. So when we run the system here, we get the voltage per unit 1.0 per unit, which is the most stable system. Next one is we increase the load value up to 50% from the initial value. We can see here 10.6 the initial value, and 15.9 is what happened if we times the initial value to 50%. We increase. And this one also for the reactive power 1.9. When we increase to 50%, you will get 2.85. So when we run the system, we will get the voltage per unit 0.971. Next one is increment load value until 75%. As we can see here, the initial value is 10.6 and if we increase the system to 75%, we get 18.55 megawatt. Also, reactive power, we get 3.3250. So this value we will insert in the simulation. We insert here, this is for the real power and this one is for reactive power. When we run the system, we will get 0.949. Okay. As we can see from the table, when the real power reach 32.4625 and the reactive power reach 5.8188, we get 0.85330 for the voltage per unit. As we know, for a system, they must have the voltage per unit from 1.1 until 0.9 voltage per unit. If below or above that average at range, the system is known as unstable. Therefore, we install PV at the bus number 30. Why? We want to overcome the high demand power from the consumer. Okay, so new PV added and it will it used as the power supply for the system because the system has been collapsed. Okay, this is the increment power to reach the system. So since we are installed PV power to the bus number 30, so we use the most weakest power and reactive power from the system. Okay, this is the 32.4625 and 5.8188. Okay, so we are using PV voltaics, yes. So PV cannot provide any reactive power, so we only the generating we will add the power for the PV in this section, which is we are using at bus number 30. So we actually include the value of the power at here. So for example, we are adding 8 megawatt for the system until it reach to a stable system, and then we run the program, we will get the answer at here. So here are our table. The 0th iteration is when the system haven't add any PV power. Okay, so this one is after we add PV power 8 megawatt and then the voltage per unit 0.904. Okay, and then we add until 16, we get 0.938, and we increase the power supply from the PV until it reach 1.016. So this voltage per unit are in power system analysis stability. Okay, so that's all from me. Thank you.
Assalamualaikum and hi, my name is RAIHANAH ROSLEE and my metric number is DE210061. So for the result and discussion, I will show my part each result. If we increment value of load before collapse negative 10%, we can see that the voltage is linearly increased to the real power. For the reactive power, the voltage is linearly increased to the reactive power. Then, for the increment value of load before collapse, 50%, we can see that the voltage is slightly decreased to the real power. And then, for the reactive power is voltage is non-linear to the reactive power. For the increment value of load before collapse, we increase to the 75%. So for voltage is non-linear to the real power, which we get the voltage error in 56.80 0.94 million watt. For the reactive power, the voltage collapsed in 10.1829 megavar. That's all. I will pass the next presentation to the next presenter.
Hi and Assalamualaikum. My name is SITI NURSYAKINAH Maisarah binti ABDULLAH. My metric number is DE 210103. So next is for discussion. For recommendation and improvement based on the analysis of this project, first is we need to put in place dynamic reactive power control system which make use of sophisticated voltage control algorithm and reactive power compensation technology like STATCOM and SVC. Second is to respond to change in grid voltage and frequency. Advanced control technique and can be used such as model predictive control and advanced drop control. Third is for the best component sizing, safeguard and fault detection method. Strict design standard and grid integration guideline must be followed. Improve steady state stability is thus guaranteed. Four is by boosting the ability of PV system to ride through fault detection and ride-through control mechanism, the system may continue to operate even when there is a grid fault, which can enhance stability and reliability in general. So next is for potential technology advancement system modification. First, if various improvement and alteration can be made to increase steady state stability of PV integrated power system. One strategy entails the creation of sophisticated monitoring and control system that make use of real-time information from the grid, PV system and weather prediction. That is to secure PV system from potential cyber threat and attack. It also essential to strengthen cyber security procedures. Last is it also advantage to take grid forming inverter into consideration. This inverter have the ability to control voltage and frequency, which is allow them to function independently and create microgrid in the event of grid disturbance. So that's all from me. Thank you.
So lastly, in conclusion, this project shows in order to ensure the stability and dependability of the power system, it is crucial to achieving a steady state during the PV integration process. The grid may depend on the PV system predictable output while it is a steady state of operating and schedule the operation of the other generation sources and system component accordingly. And to keep a steady and a safe power supply, it enables efficient power dispatch, voltage management, and frequency control. The PV integration is related to supply capacity, which is related to power generation and system infrastructure. And during steady state operation, the PV system is continuously generating electricity based on the available solar irradiation and the power output is synchronized with the demand from the grid or local loads. In this state, the system has achieved a balance between supply and demand. It entails evaluating the power flow, voltage profile, and system behavior under variable scenarios in order to study and analyze the steady state condition in PV integration. And this research aids in figuring the output, the best location and sizes for PV system, and understanding how PV generation affect the grid and developing suitable control scheme to preserve stability during steady state operation. Thus, achieving a steady state in PV integration means achieving a balance between PV generation and load demand and ensuring stable and reliable power supply. So I think that's it from us. Thank you for watching.